Stangebelisco here, a little experiment discharging a capacitor. What I'm going to do here, this is a 2200 microfarad capacitor with a 6-volt lantern battery connected across it, actually 6.3 volts, as measured on our meter here, Radio Shack TRMS digital multimeter. 47 kilo ohm resistor right there, a little tiny thing across that capacitor. And I'm going to disconnect the battery when the second hand reaches the top of the mark. Right now, let's watch the voltage drop and watch the clock. As it moves along, we can tabulate the data as voltage here versus time there. 15 seconds. It's going to take quite a long time, obviously, for this voltage to get down to anything near zero. But 30 seconds. I'm not going to burden you with all that. I'm going to go for about 4 minutes and then quit. 45. And then you can tabulate this data and plot it as a graph and look at the logarithmic decrement as it goes down. 60 seconds or 1 minute. If the resistor were larger, the discharge would happen more slowly. 1:15. If the resistor were smaller, the discharge would occur faster. 1:30. If the capacitor were larger, the discharge would take place more slowly. 1:45. Of course, if the capacitor were smaller, the discharge would take place faster. 2 minutes. Now, I plan to put this data in a book, and it'll go along with a lot of other properties of capacitors that'll be interesting for you to read. 2:15. Basically, something that every hobbyist electronics nerd should have, a little book. 2:30, little companion, little workshop book for reference. Resistors, transformers, data of various sorts. 2:45. We're down to 1.36 volts now. When it dives below a volt, it'll go to 3 minutes. It'll go to millivolts. I don't know if you'll be able to see that little MV pop up there, but this is a sort of a cool meter. It adjusts its range. 3:15. It adjusts its range as needed depending on the voltage that you actually apply to it. The same happens with other values too. Resistance, current. 3:30. This thing will even measure capacitance. And I did check this capacitor, and it's pretty close to 2200 microfarads. 3:45. And I checked the resistor. You should always do that kind of thing too to be sure that it is in the ballpark. We're closing in on 4 minutes, and at that time we'll stop the experiment. 4 minutes. 0.72 volts, and we'll short out this capacitor. Dead short it. Of course it goes to 0, no surprise there. And then we'll take the shorting jumper away and watch. It's recovering 4 millivolts. And this is the first time I've never known that that would happen with an electrolytic before, that it could actually recover just a little bit of its charge. It's actually rising. The voltage is actually going up. That capacitor apparently can remember beyond having its memory erased. Go figure. Stan Gibilisco. That makes capacitors pretty smart, doesn't it? Stan Gibilisco signing off. Until next time, so long.